All right, in this video we're going to be talking about linear transformations. So one, we need to know that a transformation is how we move a linear function. So that may be that it's not at the origin, that the slope has been changed. Really, we're going to be talking about slope and y-intercept and how that changes. So there are really two things you need to know. Anytime we are adding or subtracting something, and I'll make like a little note of this. That is doing something to your y-intercept. And that is a shift. Your y-intercept is either going to shift up or shift down. Then, anytime we are multiplying by a whole number, by a fraction, it could be a negative, doesn't matter. Anytime we are multiplying the function by something, that is dealing with your slope. And when we describe that, we describe it as the line either got steeper or it got less steep. We could be more specific, like steeper by 2, less steep by 1/3, whatever. So for number 1, if we have something that we're adding, that would be something being done to the y-intercept, so that would be a shift. It's plus, so that would be a shift up. And we can say it's up 2. And that's it. What this means is if our original function, our original line, had a slope of 1 and a y-intercept of 0, so like it has a y-intercept, but it's just 0 and it's not anywhere else. Instead of the y-intercept being 0, it would now be at 2. And every other point would also be up 2, since we're adding 2 to the entire function. For number 2, since we are multiplying by 1/3, that's dealing with your slope. So your slope is now less steep because it's a fraction. If it were a whole number, it would be steeper because you're comparing it to a line with a slope of 1. So I should write that. Compare to a slope of 1. Whoa. I don't know why I wrote brackets and parentheses. Anyway. And this is comparing to a y-intercept of 0. So for number 2, if the original slope was 1, it's now being multiplied by 1/3, so the slope is less steep. And now we're just going to put some of those into practice. So in number 3, we have to plot 3 points on this plane to create a graph that represents f of x minus 3. So if we have minus 3, that's something being done to the y-intercept. So instead of the y-intercept being at 0, 0, it's now being moved down 3. And we just need to plot 2 other points that represent this. It does not matter where. The slope here is not changing. So if you want to add that to our list of notes, y-intercept doesn't change when our slope changes. And then when our y-intercept changes, the slope doesn't change. So for number 3, I could go Since my slope of this original line is up 1 to the right 1, I can go up 1 to the right 1 from the point I have drawn and down 1 to the left 1. I could do 2 in one direction. It doesn't matter. I just need 3 points. Any 3 points would work. If you want to go all the way out here and say, well, if this was here, I would move it down 3, and that would also be correct. Same thing here. If this was right here and I move it down 3, it would now be here. So as long as you have 3 points that would work with this, you're good. This number 4, we are multiplying by 2. So that means our slope is changing. So instead of it being 1, we are multiplying it by 2. So it's now 2 over 1. So instead of it starting at, it would still start at 0. So we can use that as one of our points. But then we're going to go up 2 to the right 1. And we can do that twice in that direction, twice in the other direction, 1 on each side. It doesn't matter. You could pick. The difference between these two is number 3, you could pick any of the points because the entire function is just being moved down 3. The slope isn't changing. For number 4, I can't just pick a point and say, well, let me multiply this by 2 because we have to start at the y-intercept and go from there. For this last one, it's now giving us 2 functions, f of x equals x and g of x equals this function right here. We are comparing them. So f of x equals x is our original slope of 1, y-intercept of 0. And we're trying to figure out from that to g of x what happened. So it does not matter how you look at this, if you want to look at the slope or the y-intercept first. If we're looking at the slope first, slope is a steepness, so that wouldn't be a, that would be b. Steepness, if we're comparing a slope of 1 to a slope of 1/4, 1/4 is smaller than 1, so that would be less steep. If you wanted to, you could also graph it, and you'd be able to see when you are visualizing this steeper or less steep. Imagine like you're skiing or sledding or snowboarding or whatever down that line. Which one would you get down faster? Whichever is faster is steeper, whichever is not is less steep. Okay, and then looking at our y-intercept of plus 7, if our y-intercept here is 0, it went up to 7, so this would be a shift up. All right, we are going to do just a few more just so you see how these work. So for number 1, we have this graph. So I'm going to quickly graph this function. Start at -5, go up 6, to the right 1, 1, 2, 3, 4, 5. Oh, did I miscount? 1, 2, 3, 4, 5, 6. Nope. 1, 2, 3, 4, 5, 6. So it looks something like this. We are comparing this line to the original. Now the original is not there, but if you wanted to, the original is really number 2. So let me draw this. So if I'm comparing 1 to 2, where 2 is the original, I can see that my slope has changed. It's now 6. If I were going down this or sledding down this, let's say this way, that'd be pretty scary because it's almost like a straight drop. Whereas if I'm sledding or whatever down this, it's a pretty, you'd go fast, but not as fast as this number 1. Or if you're just looking at the numbers, 6 is greater than 1, so this would be steeper. And then if we're comparing the -5 to our y-intercept of 0, it has moved down 5 to where it was. So that would be a shift down 5. Now, that answers number 1. If we were to answer for number 2, since this really is the original. The slope didn't change, the y-intercept didn't change, so you would say it has the same steepness and the y-intercept didn't move. So if you get an example where the slope is the same, you're going to say it has the same steepness. If your y-intercept happens to be the same, you would say the y-intercept didn't move. I'm going to do one more of these. So I'm going to solve this. So we'd have 2y equals negative x plus 8. Divide everything by 2. So y equals negative 1/2 x plus 4. And I'm going to go ahead and graph that. So we're going to go up 1 to the left 2 as many times as possible, and down 1 to the right 2 as many times as possible. I'm going to graph that. Now, if you wanted to visually see this without me scrolling back up, I could draw the original on this. That way I can see both in the same graph. And then compare my slopes here. So if I'm visually comparing them, if I'm going down this, I feel like I'd get down this faster than I'd get down this. Also, 1/2, even though it's negative, by default it's less than 1. Disregard the negative because that part doesn't matter. What matters is the actual number itself. So the 1/2 is smaller than 1, so this would be less steep. And then looking at the y-intercepts, we have a y-intercept of 4 and a y-intercept of 0. The 4 is higher, so that would be a shift up 4. Right? Or if you were just comparing, so if you wanted to compare without drawing the original, just write somewhere off to the side. Let me actually write this next to it. The original, where you have a y-intercept of 0 and a slope of 1, and compare the numbers like that. You will now have time to go and practice. Let me know if you have any questions.